new project to try out. If you tuned in 2 weeks ago, we were working on a Bluetooth toy, and I'm gonna go and have a look at. We'll share a look at our repo and our outstanding issues that we put there. Okay, and here is our list of issues that we had. And this is probably even visible as a Kanban board, which is how I prefer to view them. All right, so open issues. We've got create a CI pipeline, create a Hello World program. And I think that's probably the card we'll pick up first tonight, to create a Hello World program. But we also have a little bit of background stuff to do. So Hello World program is usually going to look like just a blinking light. And our little device, which unfortunately I can't show you tonight, on account of the camera that normally looks at the device, is not playing tonight. But we have an NRF 52840 processor on a Circuit Playground 433. So the first thing I think we want to do is go get the SDK for our microprocessor. And I'm using the power of Google. So we have an NRF5 SDK. And because I've visited this before, I kind of know what I'm up to here. So we're going to do a little in-page search for 52840. And that's going to turn up. All right. So soft device, this is the this is the application stack that we're going to use. So soft device S133 gives us a memory optimized peripheral only Bluetooth low energy protocol stack. 52840 also appears. All right. So I'm going to uncheck the 112 device. There's a little check mark, say what you're going to download. The 112 device, or soft device S112, does not support the 52840. Let's go search out the next item. Soft device S140. It's a feature-rich central and peripheral Bluetooth LE protocol stack. All right, that's probably useful. That also means that one didn't have what we wanted. Now these others are hosted by third parties. They do not have they're not checked, and I'm not going to download them. Okay, so this is what we're going to download right here. S113, S140, and the core NRF5 SDK. We'll download those. And we're going to save the file. So that file is saved. And now I'm going to take us back to our Visual Studio Code. And I'm going to be a nice host, and I'm going to share the session with Butch using Visual Studio Live. And share, read, write. Oh, apparently it thinks I should really sign in with GitHub. One moment here while I sign in with GitHub. One moment while I don't sign in with GitHub. Phone had to be reset a couple of weeks ago, and we can't do that. So we're gonna do this again. All right, let's see if it's going to do the thing. I need to be authenticated. Now this is going to be a problem. All right, let's try that again. Signing with Microsoft, signing with GitHub. Hey, let's try a Microsoft sign-in. I don't have any. Two-factor authentication set up on that. Let's see how that goes. Haha! Look at that. I have something I can share with Butch. There you go. Yeah, I'm going to share a terminal as well. Look at that. We have a terminal. And if anybody's got questions that's watching along, go ahead and drop them into the chat. And if anybody's got questions that's watching along, all right. So I downloaded that thing. Have you been able to join, Butch? You're muted, Butch.
I clicked the wrong button and LiveShare tried to connect to audio and muted my other thing. So
that's about par for the course. It's been a rough week for LiveShare. I will confess that I have my own share of trials and tribulations with LiveShare. All right, so I'm going to go over to my downloads folder and device download. Well, I hope it was device download was the name of that zip file.
there.
Let's just take a look at that. Yeah, look at that. Device download indeed has all of our goodies. Oh, and here's Butch. So I'm just taking a look at what's in our goodies. I don't want to dump these files in our repo, but I kind of don't want them outside of our work area. So maybe I'm going to move these into our repo and then we'll sequester them and not check them in. Oops. Don't want to do that. Okay, we have an external directory, and I'm just going to do the sensible thing up here, make it .gitignore. So you haven't played with gitignore before, this is how I say don't use this folder. Or don't pay attention to this folder. So, even though that's there. If I look, the only thing that can see is that .gitignore. And now let's just unpack that.
A zip full of zips.
Yeah. Ain't that special? I have no idea what's in these because a cleverer monkey would have done homework before this episode, but I'm not that monkey. All right, I feel like the NRF Core SDK is probably a really good place to start looking. Okay, if you look there, it exists in its own folder, so that's what I was really checking on. So I'm just gonna delete that. Yes, it's been a better week at day job, but it doesn't mean it wasn't still an exhausting week.
Yes. Concur.
Okay. Now we have our external folder. We have our NRF section. And I'm going to be honest, I really don't know what anyone does with any of these things. But there's examples out here, and examples are like a really great idea for. We can look at an example and see how things get done. All right, which board is supported by which example? Using a 52840. Huh. Okay, this matrix isn't very helpful. It's divided by... I'm pretty sure these are NRF provided development boards, which is not what we're using. All right, so the README, less useful than one might like. Yep.
My memories are coming back to me, and my search last week or week before last for some of this, I had trouble finding things that talked about doing anything with this particular board other than the Adafruit.
Yeah,
pieces.
That's kind of the long and short of it. The people who, all the professional work with this board is not done in that Adafruit context.
Yep.
All right. Well, there's a whole bunch of stuff here about Bluetooth Low Energy. That's all to the good. Bluetooth peripheral. Of course, the first thing we probably want to do tonight, Blinky.
Sweet.
Oh, and it's by specific board. You know what? I'm just going to grab any random board. Wow, I feel like they're complicating blinking a lot. All right, all of these are designed to use a very specific IDE. That's not what I wanted. Huh. All right, well, sometimes... Oh, ARM-GCC. Let's see if ARM-GCC gives me useful stuff. Well, it gave me some useful stuff. So we are, in fact, using ARM-GCC.
Okay.
It gives us a linker map. I like that already. I can't say I was racing out to try to invent my own linker map. And
It can be challenging.
Yes, I do not like to do it. Oh, and this targets NRF 52832 series board. So that's not going to be a happy answer. Also means our linker map's probably not very happy. All right.
So which other boards do they have in there?
Well, that's a great question, isn't it? IAR. Oh, what's here in config? Oh, SDK config. All right. Don't know what any of that is. IAR. On the list of things we aren't using, the IAR compiler is high. If that's what I think it is, that's the Intel compiler. All right. So this is probably PCA. That's probably a board, a particular development board. Hey, Blinky, there's the main function. That's probably where we should start. Okay, so use NRF delay. We use boards. BSP board init, kind of a standard thing. Well, I is less than LED's number. I wonder where LED's number is defined. I wonder if that would give me anything. Aha! It's defined in 18 different places. That is perfect. Now, our board...
Well, that's because they got all the boards in there, and it's...
Yeah. That's exactly what that's about.
And I don't know why, but I see that you've got that open in Visual Studio, but I don't see it in the share. So did you open a different window?
No, it's the same window. It's I think that's a
Tricky
get.
live studio stuff.
Yeah, that's exactly what that is. And I wouldn't mind next week trying trying to hook up with that new extension from JetBrains for doing the remote share. That might
Yeah,
be
it'd be
good.
worth a try.
Yeah, I didn't have a chance to do it this to get it set up this week. Uh, I was doing day job stuff during the day. All right, so BSP board LED invert is the function for flipping a bit. That seems to be a core function. That's really pretty nice. Yeah, you kind of got to like that. That's going to be easy. That part is configuring the board. That's going to be a little fun. All right, so we probably need to.
So do we have enough here to build their demos?
I don't think so. In particular, I'm pretty sure that there are. That's a lot of text that I can't read as HTML there. Tell you what, I'm going to switch us back. So one of the things that was obvious to me looking through there is there's configuration information we'll need to provide because these are ARM boards, and if you're looking for straightforward, ARM is probably not your first choice. ARM is where you go for I want a lot of computer for not much money. Okay, let's try doing something radical. Let's try reading the documentation. Let's see if I get away with that. I do not. Okay. I'm sorry, I've got it off the screen right now. But I'm gonna do a tricky Linux thing, which is also perfectly viable on Windows. Alrighty. And okay, I am going to switch us to the browser view. And in the browser now, we have documentation for the developer kit. This seems really relevant to what we're trying to do. So we're going to go view that documentation. I'm going to see what that gets us by clicking there. Oh, that's going to take us out to a Nordic Semiconductor website. As you can see, it's spinning a little bit for reasons that are not entirely clear. All right. I feel like that's not going to get us what we want. Connection has timed out.
That's not a good thing.
No. Well, that's not what I wanted there either. All right, it is responding a little bit now. Hopefully this isn't when Nordic decided that this is a grand time to update the website. Huh. Okay. So. Welcome to the exciting world of embedded development, folks. I'm going to try...
What is the link you're going to? Let me see if I can try to get there.
Yeah, just a second. I'll paste it to you. I was also going to pop it into Chrome to see if that would work just a little bit better. Just in case there's just something about Firefox that irritates it. Chrome behavior is very similar to what we saw in Firefox. Oh, I got more. I got more. Okay. That's happier. Okay, getting started. Well, that seems like a great place to start there. Using the SDK with other boards. I feel like that's probably where we want to start. Okay, so we have to define a custom board.
Awesome.
But PCA 10056 is really close to our board. It uses the same processor. And that means we can probably just take the definitions for board PCA 10056 and tweak them slightly. To represent our board. So board custom is what we have. Board support file. Okay, for all those things that started with BSP, that's board support file. Or board support stuff, isn't it? Header files for supported boards are located in the directory components/boards. Actual selection of the file according to the defined statement is done in boards.h. The device on the legacy board, you may need to change the memory layout. Well, let's hope it doesn't come to that. A lot of pop-ups. Okay, so, yep, find an existing board, adapt it to our needs. So that'll be fine. PCA 10056 is our target board. Gonna go back to our everybody's favorite editor here. Look at that, boards. PCA 10056. And we need to put that in our just a second. We need to copy that to a file called custom_board.h. It needs to be in our path. Well, I think we can do that. With that, we've got a board. And we have if I go up here and I close that, I'm just going to drop it in our root folder for now. That's probably not where it'll stay. Actually, you know what? Let's make an includes folder right now. And we're just going to paste that all in there. Oh, wow. It even defines Arduino pins.
That's nice.
Yeah. We might actually be okay then. Because this is, I think this is the only NRF board, or the only Arduino supported NRF processor. So these are probably good. Pin 13. Maps to bus 1, pin 15. I did a little bit of research earlier looking at the schematic. Should we show the schematic for this device? I think that's probably actually a good idea.
Yeah, why not?
All right, let's go back to the browser. And this is one of those. So what I'm using is Adafruit Circuit Playground 4333. And the schematics are super, super helpful. So scroll down and things disappeared on my screen. Okay, and this is the sales page. This isn't the technical details page.
Those two green leaves right there.
Yeah, those are safety certifications.
Somewhere usually right around there they have the.
Yeah, technical details.
They have a link for the schematic somewhere in there.
Yeah, like I said, I found this earlier. Technical details right over here on the sidebar where a person might expect to find it. And that just took me back to what I had before. Primary guide. Let's try that. All right. This is where I found it before. You can see by these pictures, though, it really is a pretty board. It's got lots of lights on it. There's buttons. What more can we really ask for? And anybody who wants to get one of these and play with them, even though they're showing it out of stock here, you can absolutely buy these on Mouser, which is where I ordered mine. Okay, downloads, which is where all of our technical examples are likely to be. Look at that. Schematics. All right, what I really want to do is blink the LED. I'm going to zoom in there. I'm going to try to zoom in on this. It's just a little bit small to read. I'm not sure how I zoom in on it. Oh, I zoom in like that. Okay. So it's probably a little hard to read, but this LED is on D13, and that's an internal designation. That'll be digital pin 13. That's the bus name that that's on. And this is the, I think this is the red LED. Yes, that says red right there. This down one here says green. This is hooked to the 3.3 volt bus. Much less interesting. That'll just tell it it's on. We can make D13 blink. So I'm going to go down here, and this is the schematic for the board itself. And I found this before. Yep. Okay. Again, let me zoom in. All right. This right here is D13, which is on, this designation is $P$B15, which I'm going to guess that translates to port bus B, which is going to be port 15 pin, or bus 1, port 1, excuse me. And this device, they don't seem to be labeled A, B, and C, but instead 0, 1, 2, 3. So that, just like we saw in that example in the header file, that'll be pin 15 of port 1. Let's just go back and look at the code. So pin 13 is the normal Arduino where the LED lives by tradition. So that maps up with this nicely. Bus 1, or port 1, pin 15. So this is actually really nice. The Arduino stuff has already been mapped in for us if we want to use those references. If we want to use the native, and I kind of prefer the native API, we know what to grab. This is wonderful. Now, the other thing about this board... okay, this is saying that there are multiple LEDs. Now, in fact, we know for a fact this board only has... Because we just looked at the schematic. This board only has one onboard LED. So that's going to be LED 0, which, again, conveniently is on Arduino pin 13.
Everything else on the board is addressed through the I2C interface.
Okay. Yeah, the LEDs are a much shorter thing. So LED start. LED 3 is the one we actually have. This is... Oh, no. None of these are our LED. So we can get rid of these. We'll just have LED 1. And we're already... I have some degree of certainty that LED 1 really is at 115 because of the Arduino mappings. I'm going to stop that. LED is 1. LED active state is 0. LED list is going to be really short. VSP LED 0 is 15. I feel like none of those are going to end in happiness. Button numbers. I'm not going to sweat the buttons right now. Only to put a note on these. Let's put a to-do on these. So I2C is how we'll address most of the components, you said?
Yeah, based on the reading I did a couple of weeks ago, that's my understanding of how this board works.
Okay. Okay, RX pin and TX pin. I don't want to mess with those right now because I don't know that that's right. I'm also not sure if those are serial or if there's something else. But you thought Bluetooth was through I2C as well?
I believe so.
Okay.
I could be terribly wrong with all.
Impossible. All right, I am going to change this to Blue Fruit is what they were calling it, I thought.
Yep.
In fact, it says Blue Fruit right on the back. So we're just going to call it Blue Fruit right here. Going to correct these guards. And this may turn out to be useful for other people. I don't know. Buttons, this QSPI thing may come up. I think that's could be related to the I2C bus. I'm not sure. But I2C bus isn't going to move around because that's a feature of the chip. That's what I'm telling myself. And Arduino board mappings we know will be solid. Okay, so let's save our custom board.h. Okay, now having done that, I wonder what's next. I think your dogs are suspicious that there's some food in the offing, Butch.
No, the door's about to open.
Ah.
I'm surprised. I'm amazed that all three of them didn't just wake up and get loud there.
Well, you never know what's going to happen.
The little white one only gruffed a little bit. It's out of the norm for any of them.
Okay, so we've got this. I feel like this is about the time we should go back to those instructions. Uh, we were given some documentation. We should probably make use of it. So in our program, we needed to do a pound define board custom. So that'll be great. Examples here in the getting started. SDK configuration header file. That might be important too. We've got the examples. Yes?
So it probably wasn't all completely correct on the I2C thing.
Okay.
There's a page back on the Adafruit site back that gives all the pinouts.
Okay.
Gives a nice list of all their pins. There are some things that use the I2C interface, some of the accelerator and the two parts of the accelerometer and some of the other bit, but everything else seems to be a pin.
Okay.
Which is cool.
I'm trying to hardware peripheral examples. I think that's where we should go look. Blinky example. Ooh, Blinky with FreeRTOS. Cooking with gas.
There you go.
Yeah, we're cooking with gas, and we have FreeRTOS in here. For those of you who don't know, FreeRTOS is a real-time operating system based on queues, interrupts, and coroutines. And wow, does it make programming easier? For a Blinky Hello World, less so, but
even for that, because I mean, for the things I was doing with the ESP 8266 a few weeks back, writing code to send Morse code out through the LEDs.
Yeah.
It was super nice to be able to schedule tasks and give them a time and fire them up. And
it certainly is.
All right. That was my office mate getting going.
Okay, we can find the source file and project file, the example in the following folder. Okay. So install folder, examples, peripheral, Blinky has all of our stuff. Let's go see if that's true. Components, examples, peripheral, Blinky, is it? Yep, examples, peripheral, Blinky. All right, there's our Blinky. Our hex file. Oh, that's actually like hex file is ready to dump right to the device. I don't feel like I'm ready to be quite that bold just at the moment. PCA 1056. That's us. There's our main.c. Okay, and blinky.eu doesn't look useful. Looks like an IDE config file. I think we have to go back here to our 1056 folder. So we have blank, and we have MBR. I wonder what MBR means.
So I can see your mouse moving, but I can still see only the Nordic website.
I'm sorry. Thank you for calling that out. All right. Well, the good news is I didn't actually bring up anything on the screen, but now you know why I really want to set it up so that the stream is what gets shared for my face in our chat sessions. Okay, so blinky.u really looks like a config file. Our custom board.h looks harmless. Okay, so what I am doing over here, we're looking in the peripheral under Blinky. And we've got, this is our main file. This is the actual code for Blinky. Really simple level of Blinky. And now we need to figure out how to build it. So we have PCA.
And this is in the RTOS example?
No, this is the non-RTOS
No, this-
example.
Okay. Yeah, I was going to say they didn't use any of the cool toys.
So underneath our board, we've got two possible boards. We've got 56E and 56. It was under 56E. Well, it's kind of got the same thing. We've got this MBR, and I don't know what MBR stands for build files. I bet there's no make file at this top level, and that's unfortunate. So under MBR, I've got our ARM-GCC folder. Targets 52811. That's probably not our board. Let's target the 1056, the 56 instead of the 56E. And so this targets 52840. That's us.
Sweet.
I like this. I'm liking this one already. All right, it's got our linker script already in it. I'm telling you, full of good stuff in here. Let's see what this has got. It has SDK root. Oh, that's our SDK root. All right. That's going to tell us how to build our own make files. Lots and lots of good stuff in here. Okay, the boards, we have to fix that because it's not really a PCA 10056. That is, in fact, where we put our boards custom.
Cool.
Wow, this would have been a really good idea to write down exactly what the pound define was that I was supposed to put in. Using the SDK with other boards, that was our page. There we go. Oops, adding support for a custom board. That's the part of what we wanted. Okay, so board custom is what we put into that define. Sorry, I'm talking to a screen that you can't see.
Yep.
So we're just going to cheat here and write board custom. We're actually going to comment out this line. I don't normally like to comment out stuff, but we are hacking this.
And since we don't have this in Git, then this is okay.
Yeah, if I had this in Git, I wouldn't even bother with that because it would be obvious what we've done. All right, marks it as a Cortex M4. That's good. I did previous research to learn that that's what this is. MBR present. No idea what that means. We're using the thumb math libraries. Not sure what that means either. Hey, we've got actual floating point hardware on the board. That's what this float ABI hard means. And it has an actual floating point unit. All right. I like it. Assembler flags, LD flags. Lots of stuff about heap size. I wonder if there's anything in here about like how to flash it. Oh, look at that. There's a flash target. NRF JProg. Huh. I don't know if we have NRF JProg.
Do we think it comes with the development kit?
That's just such a good question, isn't it? It does not. So we're going to have to go get that toy. What I propose as a first pass is that we just go into the folder and see if we can even build this.
It's probably a good place to start because then it'll tell us what toolkit and other things we don't have set up.
Speaking of toolkit, guess who never installed GCC ARM?
Okay.
Well, maybe more problematic. Guess who doesn't know what his compiler is called? You know what else? Okay, project directory. Okay, we need to copy our custom board to the Blinky folder too, so that we are in an included path. Or we could do it to the config folder. That's our config folder right there. I like it. We're going to add our custom board here, copy it, and just add it in there. Look at that. All that nice stuff done for us right there. I wonder if this does us the decency of setting CC at any point. SDK root components toolchain GCC. Huh. All that stuff might be here. So components.
Sorry.
Toolchain. GCC. That does not look.
Hello?
Does not look promising. Oh, there we go. GCC ARM non-EABI. Okay, I probably do have that compiler installed.
Just so you know, my dad's in the meeting, so I'm gonna be quiet for a minute.
Just gonna do a little bit of exploratory file system work here. It's possible I don't have it on here. I haven't done it, come to think of it. There we go. I found it.
Sweet.
Not that I have it installed, but it's out there. I got lib standard C++, new lib, which is their libc. Got the compiler. Life is good. Maybe.
All right, I don't have to listen to it.
All right. We won't poke around in those deep roots any further because that'll just make people uncomfortable. We have our first reader question. are we doing embedded programming? The answer is yes. We're using Adafruit uh, Bluefruit, but with native Nordic Semiconductor SDK instead of Arduino. And we do that partially because as professional software developers, we feel shame for using Arduino. But the reality is native SDKs expose more features. And more features exposed means more opportunities to play. And also, I'm sorry, your dog's contributions are hilarious.
That's one of the big dogs, and it's almost 9 o'clock, and that's her bedtime, and she starts moaning like this when you're not going to bed with her at 9 o'clock.
Ah, I got you. You got a reverse alarm clock.
Yes.
The cat.
So the other thing about using the full build chain instead of Arduino is it's really hard to automate Arduino in a CI pipeline.
Absolutely. I have done it. It was very painful. It was most of a day to get it to build. And it was a horrible hack together mess that was super fragile. So, anyway, we have Blinky. Oops. No, we didn't get into Blinky. My bad. Peripheral. And now I'll bet there's a Blinky. Yep, there is. And we're going to change into the PCA 10056 folder. And we're going to go into the blank. MBR, I think, is for the soft device setups.
Okay.
Go to the ARM GCC folder. And now I think let's... What the heck? Let's try make.
What's
the worst? Yeah. Cannot load. If I use their local GCC ARM, not an API. Okay, that's fair. It's not going to find that one. And that's because it's a user bin, not in that other thing. Okay, but we saw weirdness out in, you know that header file that I closed? I probably shouldn't have done that. All right, so GNU install root. Okay, so all I have to do is...
Is that right?
Yeah. Just a second. Let me see where it was looking for. Oh, yeah, it just looks for it right under whatever that is. So mine is user bin. And now let's see what happens when I make.
You might need a slash there. In the make file, they had a slash.
Oh, you're right. Yep. That does seem to have led to a catastrophic oops.
Hey, look at that.
It is building.
Oh my gosh.
It is building. Oh, wow.
We got hex and bin out of that. That was awesome.
We did. Now let's go look at those and verify. I don't have the flashing program installed, so I can't do anything about it. But wow, that was pretty neat. Yeah. And the toolchain folder doesn't really have... Yeah, it doesn't have all those things that we might like. So we're going to have to go find that flashing program. But hey, We're at 55 minutes anyway, so we weren't going to go much further. So let's just take a look in our. I wonder where that file got put. Ah, there's a build folder. It should be underneath this somewhere. I have no earthly idea where that build folder is, so let's just go in there. Oh, look at all that beautiful stuff. We've got a memory map. We've got the actual ELF output file. That's the blue one that you can see on the screen. NRF 5228.hex. That's an Intel hex file, all right. Look at that. Lots and lots of instructions.
Pretty awesomeness.
That is. Let's see what's in the map. The maps are often interesting. Okay, where is all of our goodies? All right, this is all of the goodies that came out of the library, that libcnano.a. You can see that right there. Then this is each of the file, or each of the functions. Oh, that's the object file. I'm sorry. All right. Okay, a lot of stuff in there. Input sections that we got rid of. So we got rid of a bunch of stuff here. Logging front end, we aren't going to use it. Actually, a whole lot of logging front end we aren't going to use. String formatter. I have a feeling this file gets a little longish. It is very verbose about what it is and is not doing. Are these included or not included sections? I can't. Hopping down like I did, that sort of took it out of the range. Anyway, you don't get a map. You don't get a coherent map file without a good build. If your build's bad, usually the map file has got almost nothing in it. So we built something. Now I don't have the flashing software, so we can't flash it. But we're at 58 minutes right now, and I just want to thank everybody for following along on this crazy adventure. Really didn't expect to get this far this easily with our first build. It often takes a lot.
So you're gonna put some notes in the README, and
yeah,
we'll carry on next week.
Yep. See, include custom board.h and map to actual device for LEDs and buttons. Note that Arduino corresponding pins for Bluefruit are defined.
So you have a link for where you got the download that you got, and which board we based things on.
Oh, yeah. So the board uses an NRF 52840 processor. Nearest equivalent dev board is 10056. And I think I should make a point of schematics defined pin assignments are at give a link to the Adafruit page there. And I could be nice and make this okay. Look at that. We might have a schematics defined pin assignments.
So where did you download the
SDK
kit files that you downloaded?
Yeah, let me put those in too. So Nordic Semiconductor SDKs are at that address. All right, that comes out readable. And I feel like we should let everybody know what this section is so it doesn't just get tied in with the ideation section. So we have our hardware notes. And look at that. That's what we want.
Good job.
Yeah. Not bad for an hour's work. We actually got a build running on a board. It took me a lot longer than that with an STM32. With the blue pill. I love the blue pill. They've got a lot of good stuff on them, but I'm not going to pretend that was an easy build to get up and running. All right, with that, folks, we're going to sign off. We'll see you next week.